Welcome, everyone, to today's Explainer. Now, if you're a network engineer, a telecom professional, or out there as a field tech, you are in exactly the right place. Today, we're doing a highly practical, back-to-basics refresher on mastering IP administration. We're going to look at private network ranges, how we assign addresses within those networks, and most importantly, how to confidently deploy these strategies out in the field. Having a truly solid grasp of these foundational rules is what separates a good technician from a great one, ensuring you build networks that actually last. Let's get started. Okay, before we map out the overarching rules of network architecture, I want to start with a mystery. A highly relatable, frankly frustrating anomaly. Why does the office printer just seem to disappear every single week? We've all been there, right? You set up a new office, everything's routing perfectly, and then out of nowhere, a customer complains that their entire floor lost access to the network printer. It generates endless support tickets, and honestly, it kind of makes you think the printer is plotting against you. Okay, let's dive into this, because by the end of this explainer, we're going to remind you exactly why this happens and, more importantly, how to fix it for good. So let's start with the blueprint. The 3 private IP pillars. Out in the field, you see these exact same IP addresses every single day, and we all know that is not by accident. The networking world intentionally reserved 3 massive blocks of IPs strictly for local private use. Just as a quick review of the global standard, up top we've got the 192.168.x.x range. As we all know, this is the absolute standard for home networks and small-scale office configs. You know, your classic 192.168.1.1, that's the bread and butter of consumer routing. Scaling up a bit, we hit the 172.16 to 172.31 range. This block gives us a much larger address space, tailored specifically for medium to large business applications. And finally, down at the bottom, the heavy header, the massive 10.x.x.x block. This one is strictly reserved for those giant corporate networks, large enterprises, and massive internal telecom infrastructures where you literally have tens of thousands of internal nodes to assign. So whether you're wiring up a tiny branch office or a sprawling corporate campus, your whole foundation relies entirely on utilizing one of these 3 pillars. All right, moving on to what I like to call the tech laws: isolation and reusability. The absolutely crucial, non-negotiable golden rule here is that addresses starting with 192, 168, or 172 simply cannot route to the direct internet without translation. You've got to have a process like NAT, Network Address Translation, acting as the intermediary. And here's the genius part. Because these private ranges are totally isolated from the public web, identical network addresses can be reused infinitely. Right now, there are literally millions of completely different deployments worldwide using the exact same 192.168.1.1 address for their core gateway, and there are 0 conflicts over the global web. It's an incredible foundational system that lets the world's local networks operate completely independently, all while saving our incredibly limited public IPv4 addresses. Which brings us to the battle: static versus dynamic allocation. Now, before we actually start handing out these addresses, let's look at the mechanisms we use to distribute them. Behind the scenes, of course, we rely on DHCP, Dynamic Host Configuration Protocol. As a quick refresher, this is our automated system that temporarily leases IP addresses to hardware. It does all the heavy lifting so devices can handshake and connect seamlessly to the routing infrastructure, completely without manual input from a network admin. Now, what's really interesting here is the choice you have to make as an admin handling an installation. You basically have 2 paths. First, on the left, the static IP. This is manually configured by you. It is permanently carved in stone and tied directly to that piece of hardware's MAC address in your records. It never changes, which is fantastic for reliability, but it's also way harder to track across a sprawling enterprise and carries a pretty high risk of IP conflict if your documentation isn't absolutely flawless and you accidentally double assign an address. On the flip side, we have the dynamic IP. Think of this one like a rotating digital clock. It's automatically assigned by the DHCP pool. It's a temporary lease, meaning it can and will change over time depending on network traffic and lease duration settings. It's exceptionally easy to manage, totally seamless for the end user, and operates with a near 0 error rate for standard connectivity. So, let's take this out into the real world. Here is your field deployment strategy and the ultimate pro tip payoff. When you're out there deploying, common endpoint devices fall into 2 very distinct groups. First up, we've got the dynamic preferred group. Everyday user devices, things like smartphones, laptops, workstations, smart TVs, these thrive on dynamic allocation. These endpoints come and go, right? They join, suspend, and leave the network constantly, so they absolutely require the automated efficiency that a DHCP pool provides. But Looking at the other category, core infrastructure demands strict, static reliability. Devices that must always be reachable at the exact same predictable address point. I'm talking about your file servers, internal routers, managed network switches, and yes, network printers. These absolutely require a permanent, static IP assignment. And that leads us right back to our opening mystery. The anomaly of the disappearing printer is officially solved. If a client's printer drops off the network every single week, you are looking at a classic dynamic IP trap. What happened is the printer was hooked up straight out of the box using a temporary DHCP lease. When that temporary lease inevitably expires and the router assigns the printer a brand new IP address, boom, every single computer on the office floor instantly loses connection to it. Why? Because their print drivers are still desperately looking for that old IP address. You can close out those frustrating support tickets permanently by simply accessing the printer's web interface and switching the network settings from DHCP to an address outside your primary pool, lock it down with a hard-coded static IP. As we wrap up this explainer, I want you to remember this core rule. Your network is only ever as stable as its allocations. The choice between static and dynamic? It's not just a basic toggle switch. It dictates the long-term reliability and maintainability of your entire field deployment. So take a hard look at your own corporate environments and client setups. What hidden dynamic traps, exactly like our disappearing office printer, might be lurking in your infrastructure right now? Are your file servers, access points, and managed switches properly locked down outside the standard DHCP pool? Keep these blueprints and deployment rules fresh in your technician toolkit, and you'll be prepared for absolutely any anomaly. Thank you so much for joining me to review these critical concepts, and I'll catch you in the next explainer.